Hello and good morning, and thank you for keeping me company in my shop here while I work on this big old radio. I've just finished the last couple videos poking around with the radio using a sweep generator, and all the tests were done with me just contacting the grids on these tubes. And that's not the best way to do things. In fact, I think it probably threw some of the test results off. For instance, my initial tests of the front end, the RF tubes, I got this kind of response here. If I can make this show up, there it is. You know, two peaks but not lined up. But this is probably because of the way I did the test. And the reason I can say that with a little bit of confidence is because the radio works, and the stuff like I just showed you should be it works well, like it's very sensitive. So the stuff I showed you should make the radio much less sensitive. So it doesn't appear to be the case that the test result really indicates how the radio is operating. So yeah, and once again, I just can't believe that this thing actually works out of the box, so to speak, and it's all original parts. I did post a video where I asked outright, what should I do about this thing? It's all original, and if I make one change, that's gone. And I have not read the comments on that video yet because I'm not in a position where I have to make the decision just yet. I leave it all as it is, and it's a beautiful piece of original stuff that happens to work, which is kind of unusual. Or attempt to go for the high performance, fix it all up and make it do what it's really meant to do. Performance-wise, I'm a little torn on that question. So in order to get a better result and not rely on these high impedance grid circuits, I plan to do the same tests over, only contacting the plate circuits on these tubes. I'm just pointing at these two right now because I'll bet you that'll be the extent of this video. We'll be just setting up and performing the test on the two RF tubes here. That's the plan. Now, here, just for some fun, a friend of mine dropped by and gave me some vacuum tubes, and among them were a couple that looked like this. Well, I'd never seen anything like this before. And so it says right on it, I'm having a hard time reading it. You can see it better than me. Ooh, what happened there? That was strange. I have no idea what just happened to the image. Okay, let's carry on. Funny things happen in life. That was one. McDonald tube shield, patented December 7th. That's very close to my birthday. 1926. That's not close to my birthday. 1926. So what it looks like to me is this feels like hardened rubber. Like maybe this was a softer rubber out here. And the split, I'm sure this allows it to gap out so you can slide it onto your tube. This must be where you put your fingers, maybe. I don't know, it's flat here. And inside it is a sheet of metal. You can just see the edge of it there. Little bits of it shining through. So I think it's some kind of thin metal somehow embedded in a rubber boot, which is then fit onto the tube. And I'm guessing when it doesn't snap back, that you're squeezing it closed once. I've never seen that. The weird thing about this is, a tube shield needs to be grounded to really work well. How do you ground this? There's three tubes with this kind of boot on it. They all look just like this. There's no attempt to ground it. And they're heavy. Just very heavy. Anyway, there we go. Something interesting to see I've never seen before. So I'm going to stop for a bit, and when I start the video up again, I should have the connections made to do the first plate test on the first tube. Okay, so I was looking for the proper place to connect the oscilloscope when I go to do the test. And here's the tubes of interest here. Maybe not this one. This might be the oscillator tube. So the first two RF tubes are here that I'm interested in. And I need to know which one of these pins I'm going to connect to. I looked at the schematic here, and I just didn't feel comfortable knowing that they've done these in the right order, which I think they have. They've done the pins in the right order. Sometimes on schematics they don't do that, but I got out my book here to look at this. So here's the two heater pins, this one and this one. So we just kind of turn this a little bit this way, and we would see cathode here. If you notice, there's a bridging wire. Maybe you can't see it. Bridging wire right here. It appears on every one of these sockets. And what this is it's connecting, what two pins can you connect together on a tube like this? It's going to be cathode and suppressor. And in fact, that's what it works out to be. So we've got cathode, suppressor, and then if we come from the heaters here, just go back one more, there's the plate, which is what I'm after. So heaters and plate. So that's the plate. Plate, 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 all the way down. So it should be pretty easy here just to put the scope on the plate connection and look at the screen, and voila, we will find out, well, what are we going to find out exactly? We're going to find out, what do we want to find out? We want to find out, first of all, is there a nice response curve? After the first tube, there may not be much of a curve because there's only this coil transformer in here. There's no real tuned circuit. Well, maybe that is, because look, it looks like this is repeated over and over here. Well, I can't find where this is. They've got a dotted line around it like it's in a metal box. Maybe it's all inside here, perhaps. Don't know. I don't see any metal boxes that would fit this. So I'm not quite sure what's going on, but that's normal. So I will continue. We'll do the test and then think about it afterwards, so I can get on the plate of this tube, but beyond here it's IF frequency all through here. So it's just these two first tubes that I can kind of do this to. And I guess really the one that's going to be of most interest would be the second one, really. But let's see what happens here. After I go and drink some coffee, of course. Okay, so this is using my SDR to look at the output of the sweep generator. And you can see it's set about 10.5, and it's looks really stable on here. If you look over to the right side of my screen here, you'll see the kinds of settings I'm using to get it to look like this. We could even slow this down, I think. And you really get a kind of a stable view of it. Now let's just talk about what we're really seeing here. This weird shape here, all this stuff. Well, I don't know where that's coming from. It's either coming right out of the sweep like that, and we'll fool around with it in a minute and see if it changes, or it's just artifacts of using an SDR to try to do this stuff. Let me change the sweep width here. We'll widen it way out. This is the beauty of this sweeper. This thing will sweep megahertz if you want it to. That's me shrinking it back down again. So, and now let's look at what's going on with the shape. So, shape seems a little more like what you would expect. I think it's high on the ends here because the signal's dwelling here. That's why it's yellow down here too. It's dwelling because it's a circular function. And how about attenuation? Okay, I got rid of it there. Okay. And so we're using a radio. The SDR is a radio. We can see the level of signal coming out of this box, which is designed to do exactly this kind of stuff, only with televisions. And the signal looks very appropriate to me, the signal level, which is something I wanted to check. It doesn't look too high, it doesn't look too low. Very good. So I think we're ready to go. Why don't we shoot for 10 megahertz for some unnecessary reason? Let me move this over. I'll put 10 right in the middle, and I try to move the sweep down to 10 if I can do it. Hey, what's that thing over on the left there? Oh, what's that coming? Hey, where's that mirror? What is going on? So when you do this with an SDR, you get some weird stuff. And let's check and make sure that it really is crossing 10. I don't know what's going on down here. Let's make sure. Okay, let me switch back to the cameras here. Okay, the way we'll do that is we'll try to pick this up on just a regular radio. So I want to put this in at 10 megahertz here. And hold it up near the beast. And I think that's the sweet we're hearing right there. Good enough. Dialing in 10 megahertz on here. That's a bit of a problem. Excuse me while I step in front of the camera. Be around 200 on the dial. That's roughly where we are. I think in fact this might be exactly where it needs to be, or very close. Okay, next step is to start this guy up. So I'm checking heater connections, B plus connections. Everything looks okay. Good. Okay, here we go. So that turns on the heaters. Oh yes, and we need sound. Let me get my own headphones here. Okay, what do we hear? Okay, we don't worry about that yet till I put some B plus on it. We're just about ready to do that, I think. Let me turn this up again a little bit. So we're hearing the radio a little bit. Now I'm going to crank up the B plus to 150. Here we go. 150 volts. Oop, oop, oop. And have my meter on here. There. It's interesting when the it would appear when the B plus is a little low, the radio is really noisy. When you get the B plus up to the proper up in the range, the low part of the range of where the B plus can be, the noise goes away. Is that real? I don't know. I gotta keep these on. Okay, so radio's operating, but I'm not hearing the. I'm not hearing what I would expect to hear, which is a bzz sound. So let's tune who? Let's tune. Hey, you know what? I can. Hang on 1 second. I got an idea here. Let's see if I can do this without stopping the video. This would be something new. Let's see if we turn on this and we turn on this. Okay, that's good. And then we just turn on this. Bingo. Okay. Now, I'm going to tune the signal generator and see if we can cross. Yeah, that's turned up a bit. We'll see if we just cross the tuning point of this guy here. Well, I would expect to suddenly hear something. We'll go back. Nothing. I don't know what happened here. Okay, let me bring it back around the 10 mark. Oh, what is that? Okay, don't know all what's going on here. the usual state. Well, I heard a little something in the radio there. Okay, so sometimes, the radio's not working because of things. Let's see if we can find some things. I guess I didn't need to turn this camera on. We don't have the scope running. Okay, we're not hearing really anything. What is going wrong? So, looking over my connections here. Ooh. What happened there? We lost everything. We lost everything while I was... Oh, it's back. So I got this wonky connection here. What's this? That's to the sound system. This is coming from the radio. Looks like maybe the ground prongs are a little off. these connections I'm clipping on are for this meter. Should I care to get a little more scientific about things, just put it like that. Not convinced we have succeeded here at all. Let me boot up the signal strength here. Oh, that's going down. I want it to go up. That's the full Monty there. I thought this thing put out a fair bit more, but no, maybe not. Well, this isn't going so well. Let's hunt it down here. I get the impression there's nothing happening at all. We're going to have to revert to connecting this to an outdoor antenna and getting it to operate before I do this. So, okay, so bit of a usual backslide on things here. Okay, so the radio is definitely making some funny sounds. It just sounded like it came on properly for a moment and went off. Now I have the antenna ready to connect to an outdoor antenna. Wow. Ooh, that's bumping the B+ wire again. He's frozen in place. Can't move. What is it? It must be the connections up in here that are a little wonky, because I soldered the other end of the wire. Okay, I'm going to put this on the antenna, and when I do, we should hear it right away in the radio. Right away. And I'm not hearing anything. So now we have a proper antenna connected. We're not hearing anything. That sounds like a radio. I'm just looking over all the... Oh my gosh, I had the RF gain way down. Oh my gosh, that's all it was. That's what it took. Yeah, this is working now.
Luis Cabrera. Sintonía con nosotros a nombre del colectivo integrado por Patricia Tony Simón en la Luis Cabrera en la conducción.
There's two stations there. Yeah, three. That's kind of again.
Otra mujer trans. La vida de las chicas trans.
Sound like the same station twice?
Saber desde el interior del país cómo es que vivo. Así que te recibo aquí en el espacio. Y la primera pregunta contigo. Vivir en un país como Cuba, siendo trans, día a día, para ti específicamente.
So, I think it's Radio Marti. They do broadcast on two frequencies. I can't imagine they're that close together. You know, they're actually separated a fair bit on the radio dial, so I don't know what's going on. Radio's working. That's good. Now we can get back to trying to do this test. Although really, playing the radio itself is like the best test of them all. So I'm going to cut the volume here so we don't get our ears blasted. Revert back now. Don't bump that. Don't bump that, yeah. Okay. That's connected now. Put the volume up. Now the wobbler's wobbling somewhere, but not where this is tuned. So I think I want the numbers to go down. At the very, very top of the tuning range. Yeah, wow. So this is 15 to 7, so somewhere in the middle. There we are. Now the thing about this generator, I mean, this is a real challenge for me. This generator is probably putting out multiple signals here and there, and that's the spot. Okay, so now we've got the sweep signal going through the radio, and it's going to be in the coming out of the first and second tubes, and that's what we want to look at on the oscilloscope. So I got to get this ready now. Okay, so the oscilloscope, yeah, it's set right. Now I can do this thing here again. Let's just try this. This time I will only turn on this one. There we are. Okay, very good. And this is where I hook the scope up. I'm at that point. Right, and I'd already rehearsed which pin it was. Assume this is a pretty good ground connection. And we're going for the plate. Now the plate is going to have a big, so I got the scope set on AC, but very, very low, very, very sensitive. So let's desensitize it here. Okay, now I don't know, maybe I can get this to clip on. So that was the DC, where the screen flew up. I don't think I can make this clip on. There's a little nubbin there. No, can't grab the nubbin. Wish I could, but I can't. So I'm going to hold this on for now. Okay. Let's make it more sensitive. Now, we want to expand. So what I'm doing is I'm expanding the sweep width, and then we're going to retune the sweep. Isn't that something? There's 2 bumps there. I'm going to put the sweep way out. I guess it's changing frequency too, and bringing it, get a little better look at it. Now the frequency range from left to right on there, I don't know what it is, but it's big. So this represents the tuning. I'm on the first tube, so somehow we've got 2 peaks showing up on the first tube. I'm going to go to the second tube now. Second RF tube. It's much larger, so we'll shrink this down. Well, now we're down to just 1 shape. How did I manage that? Looks like I still can't clip my scope lead on. I'm going to tune the radio a little bit. Okay, that makes sense what's happening. So that is that. I think that is the legitimate response curve coming from the first two tubes. So it's the output of the second tube, and the curve is stretched out on this side. And that again might be just an artifact of the test equipment, the way I'm doing this. Well, that's. Let me expand the sweep way out here even further. So I think what's happening here is we're going off the end of the. I don't know what's going on there. Not sure what to make of that. What I'm changing is the frequency, the output frequency of the signal generator. That's, I think, is going down in no, it's going up. This controls reverse. So this is going up in frequency. We're out of the range of the radio's tuning. We're coming down. We're coming into the radio's tuning range, responsive range, and then we're going to disappear out the other side and not really see what's happening. How do you interpret that? Well, if you leave everything set like this, it's pretty easy. But if you happen to set it like that, you have a hard time explaining what the heck's going on. That's kind of the bottom line. In other words, it can't. Once again, you just sort of look at these shapes and register them and stick them in your head, and then just carry on. I'm not sure this is really telling me too much. If I were attempting to realign this set, well, that's an interesting question. The question is, I'm going to get a clip lead here. That's not the question. That's a statement. I'm going to get a clip lead. I'm going to clip this on. Here. Maybe it's better with this. put this on the second cathode here. There we are. Good show. And is this set to ×1 or ×10? ×10 here. Okay, very good. Now what? That's right. That's right. Let me get my protective glove here. I'm going to shake this guy around a bit, and we'll watch what happens on the up on the scope. Again, I took it right out. I don't want to touch the. I think the concern here with this is if you're really sloppy at putting it in and out, you can bang the contacts with the side of the can. One of those contacts, or some of them, carry B+, so you could raise the can up to B+ level. You're holding on to it, you got your hand touching the chassis, you're going to get a lift. And that's from being sloppy with this, I think. I think if you're not sloppy, you're going to be okay. What I'm interested in is this showing up here or here? Is it always showing up in the same spot? It seems to be pretty darn stable to me. That's kind of impressive. I would think if you pull this thing around and move it, that the tuning effects would change and the thing would jump around. But of course, if they made the radio that way, I mean, you have to be able to drop in one of these guys, set that to the same number, and get the same station again. Or else this radio really, it wouldn't live up to its reputation. So, as clunky as this seems to me to be, pulling out the coils and sticking them in, it seems to be effective. Okay, so we're not really getting anywhere here. I think what I'm showing is the front end seems to be okay. As okay as I can determine it to be right now. That's kind of the end of that, I think. The IF will be more interesting. So that's what we'll aim for next. We'll do the same sort of thing with the IF. Hey, what if I do that right now? What if I said, what is coming out of the IF right now? I could say that. I did say that. Let's go take a look at it. Oh, so and where would that be? Coming out of the IF is coming out of somewhere down here. I got to sort that out, so I'll take a couple minutes here. Figure out where to put the scope. Okay, I've connected to the plate of the first IF tube. That's way down here. And you can see what it looks like on the scope. It's very, very faint while this line is very bright. Bit of a problem here. I'm just going to turn the brightness up a wee bit. So it's a very complicated image. Now let's tune the radio a little bit here. Yeah. Yeah, that's quite the thing there. So this could be reflective of the signal generator I'm using. Let's change the sweep width. Well, that's really curious now. Two things. So usually you do these tests to clarify things, but that's certainly not what's happening here. What if I go way down here? So this is a very large sweep width. I think that hints to me that I've got the radio tuned far away from the center of the sweep. So let's see if I can fix that. So I'm going to tune the radio and change the sweep width at the same time. Ooh, look at what's happened here. Oh. Sweep width is doing that. That looks lovely. Right about there. That's perfect. What's this all sound like? Sweep width. And tuning. So we're past the sweep here. And we're just coming into the sweep. The mirror image thing here could be I was going to say SDR. There's no SDR involved here, Jim. Hey, that's right. We've got the SDR here. Yeah. Let me flip that on here. Just a second here. Using my new technique, which I don't like. It's going to be this right here. Okay. Okay, now we can see what's going on with the sweep. I'm going to narrow it way down. Okay, so it's narrowed way down, and then I'm going to get it on the screen here. Where to go? Okay, so you can kind of follow along with what crazy stuff I'm doing. You can sure go right by the tuning range, the tuning spot of the Where'd you go? Hey, what happened there? That kind of quit suddenly, didn't it? That seemed like the radio just quit suddenly. What happened? Anything could have happened here. Oh boy. Arr. You get too much on the go again. There's just too many factors out of control here. The radio's not receiving anymore. The radio's not receiving anymore. There's the sweep range. Right around the 10 megahertz. Come on, radio. What did you do? I didn't do anything to it. Okay, so we got B plus still. Oh, what's that coming on the scope? I didn't notice that. Let's tune the radio. So it's an audio thing that's happened. It's an audio issue. There we are. Okay, it's nothing but my audio connection. Back to work here. Well, and what was the work? I don't even know what I'm doing anymore. Okay. So, if I narrow this right down, and then I scan it around, we should be able to find out where the big radio's tuned. So, alright, do this more smoothly, coming back. 2 things on the screen, 3 things, 4 things. What is going on? A tsunami is occurring on my computer screen. Just keep going. Okay. So this is just below 10. And we're going to go way the heck out here. The level on my SDR screen, the bass level, the noise level is going up and down. I think that's really an AVC effect going on with the SDR. Let's bring this back. Around here. Let's widen it out. There's nothing on the scope. Well, that's pretty weird. A big gap there. Wow, I don't know what's going on. That's the SDR thing, I think. Jim, do you have any idea what you're doing? Yeah, I got a little bit of an idea. So, we're proving the SDR is in the proper range for the radio here. Oh, look at that, baby. There we are. There it is. Let me just stop the buzz here. There it is. Yeah. So, if the signal generator is putting out a fairly flat, like a square shaped signal, if I can put it that way, and this is what we're getting coming out of the IF, it shouldn't look like that. I don't think it should look like that. What that actually means, you got me. Does it mean the IF is tuned in various places? So we're seeing like numerous tuning peaks showing up. So all this stuff needs to be tuned into one spot. Is that what it is? Is that what it is? Or is it just an artifact of the way I'm doing this test? Or another possibility, not really alignment, is because of bad components in the radio, which I kind of doubt. Kind of doubt that. So what's going through my head now? Because again, I'm really reticent to start changing parts and components in the radio until I'm feeling more sure about things. I could play around with the alignment a little bit, especially the IF alignment. The RF alignment's a little complicated in here because it's the box stuff. I read a couple different things about it. Nothing too consistent. The IF should be pretty straightforward to do. Maybe that's the next thing to do here. I did read a comment about these two electrolytic capacitors being surprisingly reliable. So, maybe that's another reason why this radio is working. It just happens to have very high quality parts. I also read about a guy who said he fixed up his radio and he replaced every resistor and a few of the capacitors. And I wondered, what the heck is that all about? Shouldn't it be the other way around? You replace all the capacitors and a few of the resistors if you're inclined to go that far. So if the guy knew what he was doing, then that's sending me a message about the resistors in here being all out of whack, which means a lot of voltage tests to try to track that part down. But if the voltages were way off, if one of them was missing, the radio wouldn't operate at all, I don't think. And it certainly has nothing to do with this shape that we're seeing here. So maybe the best thing to do is to leave this set up just the way it is and then twiddle around with the alignment a little bit. There's some learning there I'm sure I've got to go through anyway before I can consider myself capable of really fixing this radio up. Yeah, I think that's probably the next step. Fiddle around with the IF and go through the alignment procedure. See what happens. Okay, that's great. So we finally got lots of rain here last night, overnight, and yesterday evening. It's still wet outside, but I'm going out there because the sun is coming. That's the claim, and I would like to enjoy some sun today. Great. Well, thanks a lot for watching. I'm babbling, so I'm leaving. We'll see you on the next video. Hopefully my head will be cleared by then. See ya.